Hello, my name is Jett Pavlica. This is my favorite photo of myself, and I'm a senior. I chose seam carving for my final project. But what is seam carving? Seam carving is an image resizing technique that is content aware. Content aware resizing tries to preserve the appearance of the important parts and features of an image while changing its size. It was originally described in a 2007 research paper by Shai Avedon and Ariel Shamir. The seam carving algorithm starts by searching for pixels of low importance in the image. This is done by one of a number of energy functions, the most popular of which being the simple image gradient function. After the gradient is calculated, we traverse the image to create a cumulative energy map. The lowest value in the last row of the map represents the seam that can traverse the image while removing the minimum amount of energy. My implementation includes an upgraded approach to this algorithm described by the authors in a follow-up paper. Instead of considering the single energy value of a given pixel in the image, the new approach stores three cost values at each pixel. These costs represent the potential change in energy if the seam were to be carved up and to the left, straight up, or up and to the right of the pixel. The improved algorithm considers the change in energy after the seam is removed, and so the authors named it forward energy. While it offers improvements all around, the technique really stands out in its ability to preserve straight lines. I took the liberty of updating one of the author's original ideas myself, namely finding the optimal order of removing seams. The original paper suggests trying every single combination of carving horizontal and vertical seams, and then backtracking on the cheapest one. This is insanely inefficient. Instead, my algorithm calculates the percent change between the lowest and second lowest cost seam of the horizontal and vertical cumulative energy maps. The seam with the lowest percent change is the seam that's carved, because it stands out less amongst its dimension. Now that you have the full rundown, enjoy this seam carving montage. All of the images that I use in this project were taken by either myself or a family member. My favorite thing about this project is getting to see images in the way that the computer does. Of course, the computer doesn't really see the images at all, but converting color images to gradients and cumulative energy maps allows humans to understand the data that the computer is using. This example shows a combination of seam carving and scaling that leads to content amplification. One strength of this algorithm is the ability to reduce the size of the sky without losing much texture. The algorithm struggles a bit with solid color clothing, as it sees less energy in this region, and this often leads to humans getting very distorted. Of course, the results diminish in quality anytime you push something too far. If I had more time to work on this project, I would explore a number of improvements mentioned in the original research paper. Techniques like facial recognition and getting user input to explicitly preserve areas of the photo could lead to better results. Additionally, a follow-up paper extended the algorithm to video applications, which could be fun to explore. Thank you for watching, and I hope you've enjoyed this exploration of seam carving.